Hi Calculus, we are going to learn what a differential is today, and then we're going to review how to write the equation of a tangent line, and then we're going to use differentials. So the first thing we're going to figure out is what a differential is. A differential is just the symbol dy all by itself, or dx all by itself, or dt. Those are differentials, all right? It stands for difference in y, or difference in x, or difference in t, time. All right, so separately they are called differentials. You've seen them together. You've seen them in the symbol for derivative, dy dx. When we put two differentials together in a ratio or a fraction, that's the symbol for derivative. You've also seen it in the symbol for integral. All right, the integral of the function f of x dx. This is a differential. Okay, so that's what a differential is. All right, we're going to review how to find the equation of a tangent line. Remember, to write an equation of a tangent line, you need an x and a y. You need an xy point, and you need an m, slope. If you have those three things, you can write the equation in point-slope form. Let's review point-slope form. All right, you take y minus your y coordinate. It's equal to, then you have the slope, parentheses, and inside parentheses, x minus what your x coordinate is. So, in the first example, I have given you your x and your y. You're welcome. We have x is equal to 2, and our y is equal to 7. So we need to find m, our slope. To find m, we use the derivative. The derivative is the same as the slope. So we are going to use f prime of x. All right, so let's take the derivative. The derivative of 15 is 0. The derivative of negative x cubed is negative 3x squared. So there's our derivative. Now we plug in our given x value 2 into the derivative function. All right, so we need f prime of 2. So that would give us negative 3 times 2 squared. If we follow the order of operations, that gives us negative 3 times 4. 2 squared is 4. And that gives us an m of negative 12. There you go. There's our m. Now we have enough between that and this to write our equation. So we take y minus the y coordinate 7. Then it's equal to our slope, negative 12, parentheses, x minus the x coordinate 2. There is our equation in point-slope form. Now, to check your work, you just put that in slope-intercept form. You just solve it for y. So you would bring down the y minus 7. You would distribute the negative 12 and get negative 12x plus 24. Then you would add 7 to both sides, and you would get y is equal to negative 12x plus 31. Now to check your work, I'm going to highlight it in green. You would use your graphing calculator. You would graph the original function. You would graph your tangent line, and then you should see that this line hits this curve in one spot at this point. There's example 1, calculus. Okay, example number 2. Now we want to write the equation of the tangent line that goes through this function, the sine of x, at x is equal to 1. In this case, I have only given you the x value. So you need to find the y value and the slope. Okay, so for the first step, we need to find y. To find the y value, you use the original function, f of x. All right, you plug the given x value into the original function. So f of 1 is equal to the sine of 1. That gives us a y value of 0.84. All right, so our x value is 1, that was given to us, and our y value is 0.84. All right, so there's the first step. The second step is to find m. And just like the first example, we use the derivative, f prime of x. The derivative function, the derivative of the sine of x, is the cosine of x. So now I plug my given x value 1 into f prime. F prime of 1 gives me the cosine of 1. I go to my calculator, I make sure I'm in radians, and the cosine of 1 is equal to 0.54. That is my slope. So now I can use this equation, or excuse me, I can use this point and this slope to write my equation. So let's do it. Point slope form. It is y minus the y value, y minus 0.84. It's equal to, I put my slope right after the equal sign, 0.54, parentheses, inside parentheses, x minus my x coordinate, which is 1. All right, there is my equation in point slope form. To check your work, solve this for y, graph your line that's in slope intercept form along with the original function, and make sure that this line hits this curve in one place at 1. All right, that's reviewing finding the equation of a tangent line. Okay, let's learn what a differential is and how to write a differential. A differential is just the symbol dy or dx or dt or whatever variable you have written separately. All right? It stands for difference in y or difference in x or difference in t time. All right, you have seen these differentials in the symbol for derivative. When we put those together in a ratio, dy dx, that's the symbol for derivative. You've also seen them in the notation for an integral. The integral of f of x dx. This is an integral, that is a differential. So that's what a differential is. So we are going to learn how to write differentials because it's the first step in learning to take antiderivatives of more complicated functions, which is just coming. So what we're going to do is we are going to take the derivative of both sides of the equation. So let's look at example number 3. We take the derivative of both sides. Okay, so the derivative of y, we need to take the derivative of. Now think about it. We want to write a differential, so we need a differential. I don't see any differentials in here. I don't see any dy's or dx's. So we need to make them appear, and that is why we take the derivative of both sides. The derivative of y, we are just going to call that dy dx. All right, now we go over here and we take the derivative of this. That is going to be a double chain. All right, so you have to review the chain rule. All right, the derivative of the outer ln is 1 over something. The inner as is everything else, so that's the tangent of 5x. That's our first chain. Now we start over. Now we take the derivative of the outer. The derivative of the tangent is secant squared. I'm going to make it a fraction because everything is going to be a fraction. So the derivative of the outer is secant squared. Now I plug in the inner as is, 5x. And don't forget, multiply everything by the derivative of the inner. The derivative of that inner 5x is 5. So there's my double chain. Derivative of the outer, 1 over something, inner as is. Start over. Derivative of the outer, plug in the inner as is, times the derivative of the inner. Now let's simplify that. dy dx, I'm going to write it as one fraction. So on top I get 5 secant squared of 5x, and on the bottom I get the tangent of 5x. All right, our goal is to get dy by itself. So the second step is you multiply both sides by dx to get this dx to drop out. Again, the second step is you multiply both sides of the equation by dx. So I'm just going to write it in here. I'm going to make it a fraction, and I'm going to make it a fraction. These are going to cancel out. I've got dy by itself. That's my differential. That was my goal. On the right, I just have my derivative function, 5 secant squared of 5x, all over the tangent of 5x times dx. So there you have it. Essentially, it goes like this. There's a nice shortcut. All right, y becomes dy. You take the derivative, and you toss dx on the end. That's a pretty nice shortcut. All right, let's go to example 2 and finish this off. All right, the first step, we take the derivative of both sides. The derivative of y is dy dx. We have to get the differentials to appear. Now we take the derivative of e to the 3x times cosine of x. If you remember, that's going to be a product rule because we're multiplying two separate functions together. All right, so 1d2 plus 2d1. The first function as is e to the 3x. The derivative of the second function, the derivative of the cosine, is negative sine of x. All right, so there is 1d2. Now we come back with the second function as is. The second function as is just the cosine of x. Now we need d1. The derivative of this first function, that's a chain rule. The derivative of the outer is e to something. The inner as is 3x, and don't forget the derivative of the inner is 3. So there you have it. We took the derivative of both sides. Now we want to get dx by itself. So I multiply both sides by dx. All right, these are going to cancel out. I've got dy by itself on the left. Now I'm going to simplify this thing. If you think of this as one big binomial, this term plus this term, hey, I can factor out in e to the 3x. So I'm going to put the e to the 3x out here, and I'm going to rewrite that binomial. If I divide this term by e to the 3x, I'm left with negative sine of x. If I divide this term by e to the 3x, I'm left with a 3 and a cosine of x. So there is my simplified version, and then my dx comes down. So there is my differential. Again, the shortcut. Y becomes dy. You take the derivative, and you toss dx on the end. That's all there is to it. That's how you write a differential. Thanks, calculus.